All right, here are solutions to perfect problem 1 for Math 251. We're asked to evaluate a bunch of limits. They're all kind of tricky in the same sense that if you try to plug in the given number, the number that the limit is approaching, 9, 10, or 9, negative 10, and 3, you won't be able to get an answer. You'll get 0 over 0. So we have little tricks how to solve all of them. This first one, really what we have is a hole at x equals 9. So what you got to do is factor out this x minus 9 from the top and the bottom. And the trick you use to do that is you multiply the top and the bottom by x, the square root of x plus 72 plus 9. And I'll show you in just a second where that comes from. It's hard to see here, but really then what you have up top is a difference of squares. These are conjugate pairs right here. It's something minus something and something plus something. So that when you FOIL it all together, the outside term and the inside term are going to cancel each other out. And what we'll get is the square root of x plus 72 squared, which is just x plus 72, and then minus 9 squared, which is 81. And then on the bottom, you'll have x minus 9 times the square root of x plus 72 plus 9. So it may not look like we've done a whole lot. This is still kind of a mess. But in fact, we have done a lot because the top is just equal to x minus 9. Negative 81 and plus 72 is x minus 9. So we can take advantage of that fact by canceling out this x minus 9 and this x minus 9 and saying that this is equal to the limit as x approaches 9 of 1 divided by the square root of x plus 72 plus 9. And this right here is a limit we can't evaluate. You can stick in 9 everywhere you see an x, and what you get is 1 divided by the square root of 9 plus 72 plus 9. 9 plus 72 is 81. Probably didn't need to show that extra step there. Square root of 81 is 9. So 9 plus 9 is 18. Our final answer here is 1/18. All right, moving on to the second one. Second one I think is the trickiest of the three. Whenever you have absolute values, what you're going to want to do is look at this limit from both directions. So the limit as x approaches negative 10 from the positive side, and the limit as x approaches negative 10 from the negative side of 10x plus 100. Maybe I'll take care of this step right now. 10x plus 100 is this, you can factor out a 10 and get 10 times x plus 10. And absolute 10 plus x. And same idea over here, 10 times x plus 10 divided by absolute 10 plus x, the absolute value of that. Okay, these look very similar. Maybe I shouldn't put an equal sign there. But they're actually quite different. See, the absolute value of 10 plus x, the limit as x approaches negative 10 from the positive side of this thing. All right, let's see. Approaching negative 10 from the positive side means your x value is always bigger than negative 10. In other words, negative 9 point something, negative 9.99999. So if you add 10 plus something that's a little bit bigger than negative 10, if you 10 plus 9.99999, this is always going to be a positive number down here. What's in these absolute value signs is a positive number. And that's key because the absolute value of a positive number is just that number. Right? If what's inside the absolute value signs is positive, the absolute value signs aren't doing anything at all. So we can just drop them if they're not doing anything. And instead of absolute value of 10 plus x, it's just 10 plus x. And the advantage to that is this 10 plus x and this x plus 10 cancel out. And what we're left with is the limit as x approaches negative 10 from the positive side of the number 10. And the limit as x approaches anything of a constant is just that constant 10. There's no x's in here, so this will always be 10. But over here, we'll see that things are a little bit different. It's kind of the same logic, except now this absolute value we have in the denominator, it's x approaching negative 10 from the negative side. So it's a number slightly less than negative 10, negative 10.00001, if you want to think about it like that. So this is less than negative 10. So if you add 10 plus something that's less than negative 10, you get a negative number. What's inside these absolute value signs is a negative number. And what the absolute value signs do to a negative number is they switch the sign. In other words, they multiply everything by a negative 1. So if we want to drop the absolute value signs, we have to add a negative sign on the outside, because what's inside the absolute value signs is a negative number. 10 plus x is a negative number when x approaches negative 10 from the negative side. But if you do that, we can say this is the limit as x approaches negative 10 from the negative side of, much like over on the left-hand side case, x plus 10 and 10 plus x cancel out. So it's the limit of negative 10. And again, this is just a constant here. There's no variables. So the limit as you approach anything is negative 10. So because this is different from this, the limits don't agree coming from the different directions. This does not exist. Maybe because this and this are different, are not equal. All right, finally, that's the end of part B. That was kind of a long one. Part C here, let's see, the trick here, well, there's two ways you can do this. X cubed minus 27 is a difference of cubes. So you might just know, using the difference of cubes formula, that x cubed minus 27 is equal to x minus 3 times x squared plus 3x plus 9. If you don't know that, you can figure that out by, all right, you try plugging in 3, you get 0 over 0. So what that means is that we can factor out an x minus 3 from the top here. So to factor out x minus 3 from the top, you could use polynomial long division. You could say, all right, what is x minus 3 divided by x cubed minus 27? Helps to put in placeholders, 0x squared and 0x, just to make the columns line up. And if you go through all these steps, what we write up here, so that we multiply it by x minus 3, we get x cubed is x squared. X squared times x minus 3 is x cubed minus 3x squared. Then you subtract. 0x squared minus 3x squared is 3x squared. And now you repeat what we write up here, so that when we multiply it by x, we get 3x squared is 3x. And if you multiply 3x times x minus 3, you get 3x squared minus 9x. And you subtract. 0x minus 9x minus negative 9x is positive 9x. Repeating, you put a 9 up here to get 9x minus 27. You subtract, you get 0. That's a good sign. We figured out this same thing here. Anyways, if you do that, the problem's basically done. Now what we have is the limit as x approaches 3 of x minus 3 times x squared plus 3x plus 9 divided by x minus 3. The x minus 3's cancel each other out. And so all we got to do is evaluate the limit as x approaches 3 of this polynomial, which we can do just by plugging in a 3 everywhere we see an x. Let's see, 3 squared is 9. Well, let's write this out. 3 squared plus 3 times 3 plus 9 is equal to 9 plus 9 plus 9, 27. Our final answer and the end of this perfect problem.